Now it's time to move on to Lesson 4 on fraction multiplication. And this lesson takes things from all of these three previous lessons that focused on the modeling of fraction multiplication. And now we're moving into the standard algorithm, or more of the procedural concepts of how to multiply fractions. Basically, this will go into how to multiply the numerators and denominators to get the final answer. And you can see it says we're connecting to an algorithm. The most important thing, though, about fraction multiplication is not focusing on this algorithm. We definitely want students to understand what it means to take 3/4 of 2/3 and to model that. So as you go through, continue to use the models such as the area model and things from the previous lessons to talk about what the fractions represent. So as you go through, make sure you follow all of those procedures. Here it shows the algorithm, 1 times 3 is going to be 3, and then you can move on to the next component. 4 times 5 is 20, and check your work. But if you model it at the same time as you're doing this, they see why the algorithm works. We don't want them just to learn a bunch of steps that make no sense to them. So as you continue to go through, you will have a variety of different types of multiplication problems. You may have fractions multiplied by whole numbers. And so when students are involved in a situation like this, they can remember that they can put a 1 as the denominator so that they can see that 12 over 1 is the same as 12 wholes. And then they can again multiply across. And they need to remember that fractions are the same as a division problem. 36 divided by 4 is 9. The one thing that we do want to avoid that some of the problems in the OLS focus on are cross-simplifying, and that gets a little abstract. Problems like this where we multiply straight across are not an issue, but when we want students to simplify and go reduce or simplify the fractions from denominator to numerator, that can become quite abstract for students. So I'll find an example. Here we have 10/12 times 4/7, and as you see, as the lesson goes through, it says divide out common factors. So they did simplify, which is great because they made the 10/12 a smaller, have smaller digits, even though it's equivalent. But now they're doing something like this, which is kind of complex and confusing. So let me just show you a little bit about what I'm talking about. So if we have 5, 6, and we multiply times 4/7, if we just simply say, oh, 4 and 6 can both be divisible by 2, and let's just cross simplify, that really is kind of complicated for students to understand. What you can do, though, is remind students that just like when you add and multiply whole numbers, you can use the commutative property, which means you can switch things back and forth and it still is the same amount. So if we are multiplying the numerators and multiplying the denominators together, what if we switched them? What if we put the 4 over here and the 5 over here? And you can see that both of these numbers are divisible by 2. So that's why it works for you to cross simplify. So I know if I took 4, 6 and I divide by 2 and divide by 2, or an equivalent to 1, I end up with 2/3. So I could take that 2/3 and multiply by 5/7 and end up with 10 over 21. So as this model goes through, definitely work it out the other way as well so that they understand why this makes sense. Your student should not have to do stuff like this on the end of the year assessment, but it is okay for them to practice it in the OLS, and you can see you get the same answer. So it's all about the commutative property and understanding that the order when multiplying does not matter. And you can change the numerator and the denominators back and forth like that to still get the same result. As we head to the student activity book, you will see that there are those basic problems where students will be multiplying fractions by fractions and fractions by whole numbers, but there's also mixed numbers involved, mixed numbers by fractions and mixed numbers by mixed numbers. The thing that I would recommend when multiplying mixed numbers by mixed numbers is, and I will write these down and then turn on my document camera to work it out with you. So I'm going to write 4 2/5 times 3 4/7. Also, you'll notice that they use the little dot here to show the multiplication sign. So reminding your students that that little dot is something they will see in middle school algebra and middle school math, but that means multiplication. So as we open up this problem and we see these mixed numbers multiplied together, what we want to do is turn these into an improper fraction first before we multiply. So let's focus on 4 2/5. Now remember, this 4 represents 4 wholes. So I could think about my fifths that we're using here and have 4 of those added together. I have 1, 2, 3, 4, because each of these represents a whole. So I have 1, 2, 3, 4 plus another 2/5. So I have 5, 10, 15, 20, 22 fifths. The denominator stays the same. Or we could use the method, the shortcut of multiply and then add. 22. But we want students to see why that works. We don't want to just teach this little trick without them understanding what it actually means. So if we have 22 fifths, and then we'll go back up here and I'm going to multiply, then add 21, and then add 4 more to be 25. 25 over 7. Now this is where students could cross simplify. What I would prefer is we just kind of teach them to rearrange, switch those numerators. I know that 25 divided by 5 is 5. So really, I'm only multiplying by a whole number. That's much easier than multiplying by that complex fraction. So we could multiply across to get the final answer. This lesson, like I said, focuses on the standard algorithm, but it is okay to use those models to go with it. And there's also some word problems that are involved that help the students understand how these fractions could be used in real-world situations. When we head back to the OLS, there is a unit or lesson checkpoint, and this lesson checkpoint will mimic exactly what you have seen throughout the lesson. There are not going to be models necessarily involved with this unit checkpoint, and it is going to be more of the standard algorithm. But let's take a quick peek at some of the questions, and they are randomly generated. So here we have the traditional multiply across. We multiply the numerators, multiply the denominators. But your student can use the area model and work these out on grid paper just as well. Here's another example. We have 2 mixed numbers multiplied together, but we are going to want to convert them to improper fractions before we multiply. Here it says make sure your answer is in simplest form, but we're going to multiply, but it's in the context of a word problem. A packer fills 7 1/3 boxes in 1 hour. How many boxes can the packer fill in 8 1/4 hours? So we have 7 3/4 times 8 1/4. And there's additional problems. Like I said, there are not models included with these, but it is okay to show those models. And you will notice that some of them, like the previous question, had multiple answers. There was more than one correct answer. So always read the directions, because it says, which are products for this product? including products that are not simplified. Choose all answers that are correct. Even though this is an improper fraction, it is the correct answer. It's just not converted to a mixed number. So hopefully this will help you with success on lesson 4 as we introduce the standard algorithm of multiplication.